So today we're going to be solving quadratic equations using the quadratic formula. Now if we were to take this equation and solve for x and use completing the square and some other great math ninja tricks, we would end up with this. Now in order to be able to use this formula, our equation does need to be in standard form equal to 0. Our a in this problem is going to be 2, so I'm just going to write that to the side. B is positive 5. And C is negative 10. Okay, and these are the numbers we're going to be plugging in. Our variable is x. So we're going to take the opposite of b, so that's negative 5, plus or minus the square root of b squared. The formula says minus, so bring that down. 4 is part of our formula, and then times a times c. And then all of this is going to be over 2 times a, and a is 2. Okay, we're going to bring down that negative 5, the plus or minus, and we're going to simplify what's underneath this big grouping symbol, the radical. So we're going to do our order of operations, do our exponents. 5 squared is 25. And then we're going to take care of this multiplication. Now all of this is being multiplied. Let's take that sign out. Let's see, we had negative 4 times 2 times negative 10. That's what's going on right there. So that's negative 8 times negative 10, which is 80. So that's really going to be plus 80. So again, that was just left to right. And then in the denominator, we have 2 times 2, which is 4. Okay, we still need to simplify what's underneath the radical. So 25 plus 80 is 105, and that's all over 4. And we need to think about that 105. Are there any perfect squares that go into 105? The answer is no. You could also make a factor tree to verify that. Okay, so this is actually our answer. And you might see it written out as 2 separate answers plus the square root of 105 over 4. And then your other answer would be negative 5 minus the square root of 105 over 4. Okay, you might be thinking at this point, why aren't we just factoring? Well, let's take a look at this. We know that we would need to find a times c, which is negative 9. Are there any factors of negative 9 that are going to combine to give you negative 2? No. So we need a different way. So we could do this completing the square. That could get a little messy since a is not 1. So our third option is this quadratic formula, which does work on everything, whether it can be factored or not, rational or irrational, real or imaginary. So now that we have convinced ourselves this is what we should be doing, let's think about our a, b, and our c. Our a is going to be 3, b is negative 2, and c is negative 3. And now we will plug that into our formula. So that's the opposite of negative 2 plus or minus the square root of b squared. When you're plugging in negatives, you should always use parentheses. Minus 4, that's part of our formula, and then times a times c. And it's all over 2a. It'll be 2 times 3. Now we'll work on simplifying. The opposite of negative 2 is positive 2. There's our plus or minus from our formula. We'll work on what's underneath the radical. Negative 2 times negative 2 is 4. And then all of this is multiplication, and you just want to go left to right with that. Negative 4 times 3 is negative 12, and negative 12 times negative 3 is positive 36. All over 2 times 3, which is 6. Now we'll simplify. 4 plus 36 is 40. Next, we want to check to see if there's a perfect square that goes into 40, and there is. That would be 4. So the square root of 40 can be written as the square root of 4 times the square root of 10. And then the square root of 4 is 2. So that would be 2 times the square root of 10. Okay, we know that we can't cancel just individual terms, but if there's a factor we can take out of everything, then that's okay. And we could also factor a 2 out of this numerator. So let's do that. If I take a 2 out, 2 divided by 2 is 1. And then 2 square root of 10 divided by 2 is just going to leave me with the square root of 10. And that's over 6. Now we can cancel factors, things being multiplied. So 2 goes into 2 one time, and it goes into 6 3 times. So my final answer is 1 plus or minus the square root of 10 all over 3. In number 3, we'll notice it is not in standard form. So what I want to do is move the 4 over. So I'm going to add 4 to both sides. And everything on the left here happens to be unlike terms, so we'll just bring that down. And over here, negative 4 plus 4 is 0. So it has to be in standard form first. Once it is in standard form, we can identify our A, B, and C. So here my A is 3, B is 5, and C is 4. And then we'll plug that into our quadratic formula. So X equals the opposite of B, which is negative 5, plus or minus the square root of B squared, minus 4 times AC. So A is 3, C is 4, all over 2 times A, which in our case is 3. Okay, so that would be negative 5 plus or minus 5 squared is 25. Again, remember this is left to right here. Negative 4 times 3 is negative 12, and negative 12 times 4 is negative 48. And all of that is over 6. 2 times 3. And we'll simplify what's under the radical. 25 minus 48 is negative 23. Okay. In Algebra 1, we don't deal with negative numbers underneath the radical. This would actually be an imaginary answer. I is equal to the square root of negative 1. But for our purposes, if we see a negative under the radical, we're just going to write no real solution. You might just see it written as no solution. You might see no real roots. They mean the same thing. And that is quadratic formula. Have a good day.